I come because I like to learn about what is going on in the industry. I like to hear from the contractors, especially because being an engineer, sometimes it's good to learn from the contractors what innovations they're coming up with, and obviously to meet with other folks and see what they're working on.
This conference is probably the most important event during the calendar year, so you cannot miss it. Because here you can meet a lot of people, contractor, supplier, competitors. So, as I said, it's the most important event in the calendar for foundation business, and it's too important to don't be here, let's say.
We come because we get a lot of exposure to people who use our equipment. Camaraderie, a lot of camaraderie. Even with our competitors, we come out and we rub shoulders. Everybody knows everybody. It's just one big happy family.
Well, it depends on whether or not you want to continue learning. If you got a desire to continue to learn, then you need to be at DFI.
The good thing about this conference, you can meet a lot of people over and over, so you can make a very good connection with the industrial people.
Networking's huge. There's so many people here, just from different parts of the country and the state and the world even, and just seeing what processes they're using and their design methods and their equipment, and just really a lot of exposure, and also getting connected with those people for potentially future work, future jobs.
Come join us if you're interested in anything in this industry. This is the place to be. This is it.
Good evening, everyone. This is Pranav from DFII of India office. I welcome you all to the DFII of India webinar series on practices for efficient subsurface characterization, webinar 1. So this is the start of this new webinar series under the committee DCGCF, which stands for DFII India Committee for Geotechnical Characterizations for Foundation. So in this series of webinars, we'll have the upcoming, maybe in October. This will be the first one to start off this series with. I'm happy to welcome all of you to this webinar. Before we start, I just want to go through a few quick instructions. Recording of this webinar is prohibited. An online webinar recording will be available on DFII of India YouTube channel in approximately 2 weeks' time. You can ask questions to the speaker anytime during the presentation. You can use the Q&A tab in your control panel to ask questions. All the questions will be taken after the presentation during a dedicated Q&A session. Now without wasting any more time, it's my great pleasure to introduce today's moderator, Professor A. Murali Krishna from IIT Tirupati. He's the faculty member of Civil and Environmental Engineering Department at IIT Tirupati, and he's working there since May 2019. Before joining IIT Tirupati, he was a faculty member in Department of Civil Engineering at IIT Guwahati for about 11 years. Dr. Murali Krishna obtained doctoral degree from IISc Bangalore, master's degree from IIT Kanpur, and BTech degree from SVUCE Tirupati. His research interests include earthquake geotechniques, geosynthetics, and ground improvement, site characterization, and numerical and physical modeling of geotechnical structures. He was a recipient of BRNS Young Scientist Research Award, BOYSAST Fellowship, and HERTAG Fellowship. He was a visiting fellow at Bristol University, UK, Surrey University, UK, and also University di Torino, Italy. So I welcome you, Professor Murali Krishna, to moderate this session, and I request you to take this session forward from here.
Hi, thank you, Pranav. Welcome you all for this webinar being organized by DFII India. Happy to see that there are very good registrations. We had received about 190 registrations for 7 countries, and several of people joined, and more people are adding onto the list. They're joining the program. Welcome you all. to have this very wonderful session planned, very important session as being organized as part of the DFII committee for geotechnical characterizations for foundations, which is we calling that a DCGCF DFII committee. And as part of this committee activities to increase the awareness about the geotechnical engineering investigations and its practice aspects for the application of the foundation design. So we plan to organize a series of webinars just to make the students, practitioners aware of various activities, what's happening. And as part of this first webinar, we are having it today. And the talk is on the practices for efficient subsurface characterization that is being presented by Dr. C.R. Parthasarathy. So he will be talking on case studies on problems, challenges, and solutions to site characterization. So I'll be briefly introducing the Dr. Speaker today, Dr. C.R. Parthasarathy. Dr. Parthasarathy started his career as geotechnical engineering in 1993, involved in numerous large-scale projects in India and abroad, and both offshore and on-land projects, which encompassing a lot of structures, multi-storied complexes, refineries, embankments, bridges, water retaining structures, offshore platforms, pipelines, etc., jack-up rigs, etc. Encompassed, he covered all the structures, important structures, inland, on land, offshore structures, and nationally, internationally, having very wide experience. He has delivered about hundreds of lectures in various forms on site characterization, deep foundation testing, and case studies. He is also a technical partner of Pile Dynamics USA. He is instrumental in promoting the quality testing of deep foundations in India, Middle East, and also authorized trainer for high strain dynamic pile testing. He has trained already nearly 1,500 people. He has achieved expert level in the PDI and PDCA proficiency test on dynamic measurement and analysis. He is a fellow of the Indian Geotechnical Society, elected National Executive Member of IGS for 3 consecutive terms, and happy to share that we partnered several occasions in the several meetings. And he is the past chairman of IGS Bengaluru chapter, and currently he is also the executive committee member of DFI India, and particularly he is the chairman of the DCGCF committee, who is taking active role in various activities of DCGCF committee activities. With this brief introduction, I invite Dr. Parthasarathy, who is the founder, chairman, director of Sarathy Infra, to deliver the talk. So over to Partha, please.
Thank you, Professor Murali Krishna. Thank you, Pranav. Good evening, good afternoon, good morning, in whichever the geography you are logged in from. I hope I am audible, loud and clear. First of all, I thank DFI for giving me this opportunity to share some experience. The topic of today's presentation will be case studies of problems, challenges, and solutions to site characterization. So the sequence of presentation would be as follows. I want to set the context of this presentation today, briefly discuss about the procedures and process of conventional, very routinely practiced methods, SPT, sampling, laboratory test, how these are interrelated. I want to exclusively discuss on small case studies, but it's very, very important one with the object of the Committee on Site Characterization. How relevant is the skill development for the success of any project. Within the time allotted, I'll try to complete that. We'll have the question and answer, feedback, and finally to wrap up. So friends, today We are in Industry 4.0, fourth industrial revolution. We have so many futuristic technologies that we need to adopt. Internet of Things, artificial intelligence, machine learning, big data analytics, also relevant to geotechnics, advanced robotic, automation, 3D printing, etc., etc. So these futuristic technology have an economic transformation in increasing efficiency and productivity if we use it rightly. Enhanced innovation with newer business models being developed, and of course also lead to global competitiveness. It does also have a societal impact. There's a job transformation and skill development. So I'll touch upon the very important aspects also during the course of this presentation on the need for the skill development, which leads to improved quality of life of people. Of course, doing the right thing at the first place invariably contributes significantly to sustainability and also reduce any impact on environment, assures safety levels. And these futuristic technologies doesn't come without any challenges and considerations. We have a lot of data privacy and security when humongous data is being transferred. There is a digital divide. Access to technology is only to few sectors, few set of people in few geographies, while it is absent in many sectors to many people. Before even talking about the futuristic technology on this digital divide, there is also equally the divide in our conventional practice, which I wanted to highlight and emphasize in today's practice. Ethical and social implication. Good education is the means to overcome this regulatory framework. Probably we will not talk because of the paucity of time list. So as we all know, any kind of structure is a small residential building or a tall towers built on deep foundation or shallow foundations are subjected to distress. Slope stability failure, even in the recent Wayanad slope failures, hundreds of people lost their life. We have cases where residential buildings are under distress. A common man like you and me, we put our life savings on a building, and then we see that the buildings are under distress. We can't live peacefully and happily. Sometimes decisions are made without taking cognizance of the risks involved. Slope failures in cut and cover tunnel. I had an opportunity to visit in one of the sites in northeastern part. No protection, no planning, no safety, and it's all non-technical activities to do work in less time, shortcuts. Okay. We also are familiar with the information available on the public domain. There are several structures that are under distress. Bridges are collapsing in Darjeeling, Arunachal Pradesh, Kolkata, you name the city, right? Stunning footage of foundation failure of a 3-story building collapse in India. I also had an experience of a building just adjacent to my own apartment lived few years before, with loss of 3 lives. One of them was my security, who has nothing to do with the adjacent building, but he was a prey to that incident. Delhi building collapse is a classical example of a tall structure collapse. Recently, 14 Bihar bridges collapsed in 4 weeks. As professionals, it's unacceptable, I think, to every one of us here, right? Sometimes doing shortcuts leads to major defects in the foundation, perhaps erroneous designs leading to higher risk, time overrun, cost overrun. Economics and safety has to be considered. The bridges built unsafe leads to disaster if it's not attended to. is just not the problem in the on-land infrastructure, but also in the marine offshore condition as well. We know structures are failing. We have these jacket structures coming down, which was just appended. Right. So friends, what are the causes for these challenges and distress? This high failure rate and infrastructure collapse leads to loss of life, loss of money, bad reputation. It's not good at planning. Rushing takes priority over managing the risks. Financial constraints on projects. More importantly, not using technology, not having skilled people on the project. I emphasize this very strongly because of having some experience in the presentations that I make and also that what I hear. It's too late in the game and then people think that they can fix it later. How can we mitigate this? Create awareness, bring in technology, induce skills, transfer knowledge, and have people the experience learning. Okay. So one of the objective of the committee of DFI on the ground characterization for foundation is to impart skill and knowledge to people so that they can be a better engineer, they can perform better job on their roles, not only for the engineers, but also the supervisory level, the technician level, on the laboratory side, on the field side, on the investigation side, on the design side, so many objectives. Okay. So why geotechnical investigation and site characterization is required and necessary? The investigation is a prerequisite for safe and economical design of the substructure element. It is also necessary to obtain sufficient information for feasibility and economic studies of a proposed project. So this will pose a very important question. What is sufficient? The characterization shall be sufficient enough to depict a three-dimensional picture where you can map the lateral continuity or discontinuity of the layers horizontally, as well as you try to strategize the layers vertically and develop the strength parameters. And these information are used for the design of foundation. So what is the outcome of a thorough site investigation or a proper site investigation? A, you get to know the stratigraphy. B, you then to know the strength parameters. C, you know what are the risks that this stratigraphy poses on the intended projects and how to mitigate those risks ahead of time so that you can eliminate all those hazards and be successful on the project. When you're talking India, $1.5 trillion of investment into the infrastructure pipeline is committed from the government in the next several years. They are going to build huge infrastructure across the length and breadth of the country. At this scale, we have serious conflict of the resource available. There is a capacity demand conflict. And it's just not for the infrastructure and other development happening in India alone. India is producing talent pool that other parts of the world are also looking at. The entire Middle East, we are contributing for the projects. So I urge this esteemed audience here, my fellow colleagues, my friends, we should help and do whatever is necessary to build professional civil engineers of highest standard, higher than anywhere else in the world, because India is a destination for human capital and the world is looking for our human capital. Now, across length and breadth of the country, the geotechnical conditions are not similar. one size doesn't fit all. So you have residual deposit in place like Bangalore. You have overburden, you have a sheetrock at the base, then intermediate between the overburden and sheetrock, you have a refusal stratum or a transition layer. We call it as weathered rocker. So the colored zone you're seeing is Blackcotton soil, highly expansive. The northern part, the alluvial deposit, no bedrock, is all overburden. Along the coastal side on the east coast and the west coast of India, you see deep-seated soft clays. So our characterization should fit in to these geographies. So one size doesn't fit all, and therefore you need to have a different approach in all these geographies. So routinely, standard penetration test has been practiced decades from now, more than 85%, and is one of the most used method in the geotechnical characterization, but apparently is also not standardized practice that has been in the field. So I want to emphasize few case studies to see how it can be mitigated and how is the current practice going on. So the first-hand information when you look at the data is always the best information. The person standing on the site, maybe a senior technician or an engineer, he look at the samples. He says, yes, this is an undisturbed samples. You're driving the SPT split spoon sampler into the virgin ground. Click pictures, record it. Huge value for this information, and also the quantity of material that is collected. So all the drill fluid, the wash cuttings are taken out. You're also ensuring that the penetration is happening into the virgin ground. If you have a very competent material, refusal stratum where the split spoon is not penetrating to the hammer blows, at least you know that these are the original material that you have hit, and you are confident that there is a competent material at the intended depth. These are very simple things, ladies and gentlemen, but it gives immense value for you to make decisions in the current scheme of things. Even in sand, you need to know if this is a real undisturbed ground or a virgin ground you are conducting the test, or is it something else, right? Many more. So it should be a practice that we need to collect on-site first-hand information with proper testing. Oftentimes, we also see that there are no samples recovered on the test because it's very, very competent, and boreholes are continued without doing any other remedial measures. So if you see a refusal with no samples, the next thing probably is very competent. You may have to core it to see if there is any material that is coming out. But we see oftentimes that the boreholes are continued and these no recovery samples continue to the end of the borehole. So you don't have sample and you're only left with a refusal. R value, sometimes it's 100, sometimes it's 50, whatever the user writes there, and we have to deal with that. Conducting this test itself, although it's standard penetration test, it's not standard. We are not sure of how much energy is transferred to the drill rod. So we have actually calibrated several rigs operating in the region, and we found that those tests performed with a rope and a pulley just imparts about 25 to 40% of the energy transfer. But if you use an auto trip hammer, which the codes prescribes, we'll end up having about 55 to 65%. With the conventional empirical equations, we do not want to have any adjustment if you use an auto trip hammer, but there is a huge adjustment which over predicts the bearing capacity. Okay, and therefore it's imperative that we have to calibrate the rigs that is operating on a project. We did that on many occasions. Several of the rigs, we found that again this 25 to 40% with more database. In fact, this energy measurement started with the high-speed rail project during COVID time in India. So the Japanese wanted to have this measured for every rig, and now pretty much being a practice. Although it's not 100%, still important projects energy measurement has been made, but equally there are projects which don't even prescribe this energy measurement. Our Indian Standard Codes IS 2131 specifies that field correction using energy measurement, but not mandatorily, but as an option. So I hope in the subsequent revision they make it mandatory. Although in the Western world it becomes pretty much common in most of their projects. If you are using a high-end drilling rig with an automatic hammer, you also tend to have a very high energy transfer of 80–90% and above is not uncommon. So when you're still using the current empirical equations, so not correcting this high energy transfer will be detrimental for economics of the foundation. Just to give you an example, a pile capacity based on only the overburden correction, and this is based on field corrections using the energy you are multiplying a factor of 1.3 or 1.4 as the case may be. For a 600 metric tons of required capacity, you end up having a 7-meter difference in the pile length. And same way, if it is for 1,000 metric tons capacity, too, it's 42 to 47, 48% is about 6–7 meters of pile length. Thousands of piles you're constructing and huge cost savings you can economize. And this economy of foundation, not only on piles, we have seen also there are published literatures on tank foundations not doing ground improvement because they have adopted the corrected N values based on energy measurements, which otherwise would have costed them millions of dollars in the ground improvement. So field part is one, so you need to have good first-hand information. Properly, you should be able to identify it is a good sample, a bad sample, energy measurements, and correct it and normalize it. That will actually elevate the standards of work that we actually are doing. So now, in situ test is one part, laboratory test is another part. In order to perform high quality laboratory test, you also need to have high quality undisturbed samples. So we are having varied samplers, okay, although prescriptions are to use a Shelby tubes, which has a good area ratio that can make the samples as high quality and least disturbance. So this should be a practice, and most of the cases today we are seeing these tubes are driven in the ground because there are no capacity of the rigs that can push statically. So many projects drives the undisturbed sampler, which actually disturbs the samples too. And when we are performing a high quality, sophisticated test, no matter how high quality or high value those tests can bring in, these samples are very, very critical for those to meet those objectives. If you are able to push good samples, even in soft clays, you can recover high quality samples. But oftentimes, if you're not taking care of the drilling process, you may end up having all the fines washed away, and you see those wash samples coming to the grounds, and we're trying to collect on a plastic bag, and you characterize that these are all cohesion-less material, although the matrix is different, as a mass is all clay sand or sandy clay. So we end up having the wrong classification of the material. And same thing you're seeing on the left side. These are not the gravels and the pebbles. These are clay sand with some amount of gravel. Well, all the fines are gone because you're not able to wash the boreholes properly, and thereby you're ending up in wrong characterizations. So wrong characterizations also has a cascading effect on your decision towards the life cycle of the project. Rock course is another important aspects. Once you see the refusal stratum, The next step is to see that you can collect core samples using the core barrels and the other tools. Very important aspect here is to ensure that you are using the right type of tools, particularly the bits, the reamer shells, the core catchers, and what kind of bits are using. So what is its hardness depends on the material that you are coring in. Here, you definitely require to understand these drilling aspects, coring aspects, and what kinds of tools are necessary. Otherwise, using the wrong tools will end up not having any progress, or you're going to have some bad quality core samples. Even using triple tube core barrel is not an uncommon practice. It's definitely required for a transition layers in residual deposits to collect those intermediate layers and quantify those layers. I'll give you one example. When you have overburden up to 9 meters, then you have this refusal to SPT. We just record it as n equal to 50 and to all the depths until about 20 meters. And then you have this bedrock. So there's no core recovery, there is no RQD. So we end up having only n equal to 50, maybe no samples. And we tend to use those n equal to 50 or now n equal to 100. Then you tend to evaluate your bearing capacity, pile capacity, and so on. But with simple change in the tooling, you tend to use a triple tube core barrel and try to core the material. You will end up having good core samples with decent recovery and also good amount of samples that you can test to ensure your unconfined compressive strengths are measured around 3 megapascals. So in the absence of triple tube core barrels, we tend to underpredict the bearing capacity. But more than just the bearing capacity scenario, it also leads to other risks. For example, the excavation in this material. So if you have a pokeline which can excavate rock, I mean this overburden, and for sheet rock, you have many other means of excavation, diamond cutting and others. But for this intermediate layer is neither a overburden nor a sheetrock, so there's always a conflict. As we speak, I know there are 2 projects under litigations between the owner and the contractor because it's not quantified properly. So proper quantification helps mitigate these risks and also avoid conflict, which can also minimize the time and the cost overrun on the project. So with this simple quality on the collection of core samples using triple tubes, you can actually predict a higher pile capacity, or foundation capacity, just as an illustrations I've given here, based on n equal to 50, where your allowable capacity on the point bearing is around 5.5 MPa. It could be around 1 MPa because you have a measured under unconfined compressive strength. Now, our IS code also gives a guideline to classify this rock mass. So these are sheet rocks, broken pieces, but if you tend to classify this rock is classified as a poor rock because it's already broken. So is it so bad that you tend to break this? Is the rock so bad that you get these broken pieces, or is it something else? I think it's drilling disturbance having mechanical fractures. So when you have this rock mass rating with these mechanical fractures, you want to classify this as a fair rock. But apparently, if you use some good drilling tools and collect good core samples, I'm sure you can get a nice core in this kind of fresh rock. Your fair rock can be classified as good rock. So in such case, the experienced geologists tend to group those core samples and then tend to improve the RQD. I don't encourage this. This is the last resort. But for all our young colleagues and friends here, you please try to do good job at the first place. Okay. So in trying to group, you're improving the RQD, then you're trying to improve the rock mass from fair to good. This is a last resort. I repeat again, but the first thing is to ensure that you collect high quality core samples by implementing good practices, put a good rig, put some good geologists on the site, and also use some good consumables on the project, like your drilling baits and other toolings as appropriate to the material encountered, and thereby you'll be able to recover good core samples. Let me illustrate a few examples, and then we will take some questions. This is a very small project, small site, 30 by 40 feet. One of the owners was intent to build a residential building of 2-3 floors. As usual, you tend to do a borehole by manual augering. It's very common in Bangalore and other regions. I've seen that manual auger is used, and you tend to get your N values. And the owner of this building is one of the project management professional who handles crores of rupees projects across the country. When you look at these N values, which is very, very weak, around 2 to 4, is little concerned on his own building. Then he said, no, we don't want to go by this. So let's have another investigation using a machine. A hydraulic machine, you make energy measurements, then results in the N values higher than what the auger boreholes has gave you, right? This again, conflicting information, puzzled, further unable to make decision. Then you tend to correct it to overburden the energy, and then you get this, okay? There are two values available for you. What is right? Don't know. So people are puzzled. The only way that you can decide on this is to have first-hand information on the ground. If the people on the ground does not give you first-hand information, then it's very, very difficult. So better you go to the site to look at surroundings, you look at the soil samples, and you can arrive at from your own judgment. From this investigation, there were some samples that was collected. When you actually examine the samples, this was tested for shear strength, and the sample is standing on its own. Okay, and it yields a undrained shear strength of about 50 kilopascal. So when you examine this soil, these are stiff clays, right? So when stiff clay, the N value cannot be 2 or 3. It should be slightly higher. With our normal correlation of 5 times N is your shear strength, you backward the N equal to 10, which corresponds to those values developed by the machine, not the auger. So high water table, the auger boreholes, you tend to screw the auger into the ground, and with so much of force you tend to pull, there's a suction created which actually disturbs the ground, and you perform an SPT, you will not get any value that. So it's simple technique, and I able to analyze this because 30 years back, I myself have worked for 5 years on these auger boreholes, about 600 to 700 projects. So something is not correct there. And when we look at the samples, it's showing something different, contrary to the N value measured by the auger boreholes. Then we discarded that and had the values from the machine. And look at the site, the adjacent building is constructed for 4 floors and is standing just next to this building. So which also gave confidence that what you have evaluated is the right thing, and we asked them to proceed further for the construction. So the building This is the adjacent building already standing for 4 floors, and this one about 2-3 floors. And finally, the building was completed. Now the owner is happy in the building. So what is one thing that we can relate in this project? The proper skill that you require to identify a soft clay against a stiff clay. Simple things, but we are not having this skill on the site, on the projects, most of the cases. Another one, this was one of the project in Andhra Pradesh. They had a huge land parcel. They planned a 23-story tower on one side and a commercial building on the other side, a small piece of land on the commercial side. A local contractor was engaged to do the investigation, and all that you have is only this information that you are seeing on the screen is N values. Is this a standard N value? Is it measured with energy? No information. I'm sure there is no energy measurement, nor the practice was a standard practice. There was no auto trip hammers, I believe so. It's rope and pulley, and even the rope would be a wire line, steel wires that would actually give you very wrong information on those measurements. So this was used by the consultant, and you see the N value plot so nicely. All of them are plotting together. It's very surprising. And for these N values, it was concluded that you have to go for a pile draft system, that the current stratigraphy is unable to withstand the load from that high-rise building. So the stratigraphy and the strength parameters, the consultant said that, in my opinion, the pile draft system appears to be more appropriate for the site. This costed a lot of money for the structural engineer, and he was not happy, although structural engineer himself has visited to the site when the excavation was made. Somehow he himself felt that this is contrary to the site conditions. So a reinvestigation was proposed, and here are the boreholes where the reinvestigations have been performed. The samples were collected, and you could see those refusal stratum at a very shallow depth. And the refusal stratum was not even met up to 35-meter depth in the initial case. And there are cemented rock layers, cemented compact material. And it's totally different, 90 degrees, 180 degrees apart from the previous investigation to this investigation. So with this information, which is the latest information, looking at the first-hand information, there wasn't any samples also in the earlier investigations to look at. You have very high confidence that you can vouch for this material because you have physical observation, and also the samples are collected and you are testing in the laboratory. There are field tests also being performed. Then the ground model was developed. And finally, it was recommended to go for raft for the high-rise building and the normal isolated footing for those commercial building. Okay. Now, in the building, 2 months back, they already started with isolated building and intermittent raft. I think now probably several floors would have already come up now. So there's something common between the previous one and this one. So what is common between the previous and this one? Please type out in the chat box. I'll come back and see after my presentation. So I acknowledge the team that was involved in this project very professionally at all stages, including the site, for thorough management data acquisition from the site, in situ testing, there were geophysical methods, pressure meter, and so on, laboratory tests performed, and also the engineering report, which apparently saved, I think, crores of rupees to the project. We did not get paid for many crores, but we are talking about sustainability. I think doing the right thing at the first place is the way to go, right? And we had similar experiences in the past, several years before, on this building, Mantri Aspana, and this is Zenith Towers. It's on the airport highway, doing a reinvestigations and actually eliminating pile foundation on this project, tall towers. Where is necessary, you don't need piles. Where is necessary, you tend to use piles. So thorough investigations is required. So on any project, and this can come only when you have right attitude with the right people at the right place at the right time. Okay. This was a refinery project for a tank farms. So one of the tank farms, I just picked up 2 boreholes here, which gave N values, as you can see here, location 1 and 2. And you have the refusal stratum below 15 meters. But the rods that were used was not standard rods. It was non-standard rods. Then you tend to redo it on a bump over borehole. Okay, it's an adjacent borehole. That repeat this again with standard boreholes with standard energy measurements. You tend to have the N values contrary to the previous ones. Okay, now you put everything together. Some of those rigs telling you it's a refusal stratum, and the other rigs are not indicating any refusal. Same contractor with different rigs or different contractor, doesn't matter. As long as we follow the procedure, I think the data should be okay, right? We tend to use that. The second one that gave you less N values only because this also corroborated very well with an adjacent CPT test that was performed up to the depth intended. So the CPT and SPT correlations gave confidence that we have to use with the standard rods and ignore those values that gave from a non-standard rods and not having any energy measurements. Okay, this has a huge impact on the foundation assessment, particularly when you are making settlement computation on the projects. So thereby we are able to solve these problems and overcome the risk that would otherwise have predicted lesser settlements than the current ones. Is it the problem only on the infrastructure projects? No, there are some issues also in the offshore conditions. To illustrate a couple of them quickly. Jacob rig foundation assessment, you could see this load penetration, leg penetration curve being generated. This is the maximum preload. The peak bearing capacity is P and M is the minimum bearing capacity. 2 factors is important. One is the factor of safety, peak bearing capacity to the preload, and the measure to required strength ratio. This should be close to unity and this should be more than 1.5. So you don't have any failure or rapid leg penetration. So well data acquired offshore with the highest standards. You could see continuous sampling. You also have an adjacent borehole conducting CPT test with proper stratification. There are crustal layers starting from the seabed as very soft clays, then firm clay, then you have the crust, then you have the stiff clay, and then it's increasing shear strength with depth. The contractor arrived at a 32 meters of leg penetration. With this leg penetration, which was predicted, the rig that was chartered was not usable on a project because it didn't have enough leg length. The client was puzzled. Then we really looked into the data. and we predicted it could only be 9 to 14 meters. How confident you are on these predictions, contrary to the contractor? This was about 10 years back. Myself personally was managing this large-scale geotechnical investigation. And I made a decision to terminate the borehole at 35 meters because I predicted the rig will stop at the top of the crustal layer because there's a stiff clay at the bottom layers. And you need to have around 1.5 to 2 times the diameter of the foundation, or the spud cans we call, below the predicted level. And that 35 meters were good at. So I was totally confident because you had first-hand information, you had a feel of soil for yourself, and then you had measurements witnessed on board. So the client did use this data, and the rig went to the location. It had experienced similar penetration, and later on the jacket was installed, and we also involved with another contractor for the pile driving monitoring as well on the same project. So why this contractor predicted deeper penetration is because not able to develop a strength profile, particularly undrained shear strength, what was relevant onto the site. So under predicting the shear strength lead to deeper penetration. 10 years later, now the last few months, I had an opportunity to interview this gentleman who was a drilling manager earlier, now became the president of an oil company. So I wanted to feature him in one of my upcoming book. So I had a pleasure to meet him just a couple of months back. How much time we have, Pranav? Another 5 minutes?
Yes, sir.
Okay, thank you. So all these cases are leading to something in common. I want you to reflect, all of you. So I will have a discussion with you just another few minutes. This data, I got this in 2009. I kept the same scale still today because the left side, the data, you see the undrained shear strength versus depth. This is on UU triaxial, and the other colored red and blue ones are mini vein and tar vein. This is measured in the offshore environment. So with this very low shear strength profile, you end up having the leg penetration like this, which is going to indicate that the legs will have a rapid penetration from here until here. No warranty surveyor will approve this kind of high risk location. There was something not okay with this data because there were many rigs operating in the region. Client was puzzled. Then it was decided to go back and redo the investigation. So expensive, costly affair. Now everything is on top of each other under strict supervision, both the in situ testing as well as the measured shear strength, unlike the previous case. Okay, so this resulted in no risk where all the legs of the jackup rig would stop at the top of the layer. Similar thing. Wrong characterization of the soils. The tar vein test we use is so simple test. Okay, you need to actually put the blade into the soil and tend to shear with the uniform vertical pressure. But the skill of the operator who does the test is very, very important. Instead of shearing during the process, it tends to slip. It under predicts the shear strength. That's one reason. The other reason is the calibration of the proving rings was not available, and therefore they used the wrong conversion factor and reported to have very soft clays, although the clay was stiff clay. But if the person doing the testing is not able to feel for himself whether it's soft clay or stiff clay, if you're just punching your finger into the material, you should be able to analyze, you are able to find out what is the consistency of the material. That is where the skill is required. Okay, it's a huge cost. Last one is a shallow borehole, 3-4 meter borehole. You see water content is around 40%. The CPT data tells us cohesion less material, very loose in relative density. So this is a Jamlowski curve for interpretation of CPT data. When you go to the lab scale, laboratory, you tend to have different moisture content and also friction angle of 38 degrees. This is for a pipeline project. If you have this disparity in the parameters, it has a huge impact on your pipeline design. If dense sand, the pipeline will not undergo any embedment. It has issues with your lateral buckling or the stability of the pipeline. But the material is very loose and the CPT is penetrating with a very low cone resistance. So you can't have a contradicting information between the field and the lab. Okay. And this one again, description of the material is also equally important. You say it is sand and report friction angle, but when you look at the same sample having a grain size distribution, it end up having 82% of clay. So should you consider drained case in your analysis or an undrained case in analysis? People puzzle. A lot of rift between different stakeholders on a project. And finally, this is a clay sand. Okay, it's not that 82% somewhere is wrong. We're trying to investigate. So all of them has one thing in common. So can you please put it in the chat box? What did you find one thing in common in all these case studies that I have just explained to you? So in summary, you need to have an integrated approach of site survey, which I did not talk today on geophysics because of paucity of time. Energy calibration is very, very important to normalize the N values. Advanced laboratory testing mandates high quality undisturbed samples. So this requires good rig and tooling as well. At times use proper machines and tools, including triple tube core barrel. Otherwise you will end up not having any samples in those intermediate layers or a transition zone, and a lot of conflicts and hazards. Proper quantification if these materials enable to choose appropriate excavation methods, design of foundations and eliminate risks. Right now we need to migrate to electronic methods. We are talking of technology. Every location should have a GPS coordinate, automate many of those processes, digitize the existing database and benchmark the usable. So we have some problem of using large database. Last 30 years we have collected, but benchmarking the quality of data is a serious concern for us because it's not uniform across all the information that is available. So at least if the standard practice is carried out on the site, at least from now in the next 3-4 years, probably those data are usable data, and then we are talking to train the models using AI and ML, develop a robust data acquisition system. One thing I want to emphasize, ladies and gentlemen, we need to have qualified, trained, certified, skilled resources, no matter what, that should be deployed to the project, which will eliminate a lot of risk to a great extent, and it will save a lot of money, time, and efforts. India is going to contribute for the global development, and I'm sure it's each one of our personal and professional responsibility to ensure that we build the next generation engineers. So I try to acknowledge Dr. Mauli and Ms. Minu, who tend to pull out these informations and put it in the format. They also have contributed to one chapter on this book, chapter number 17 on soils and rocks of Karnataka state. So please go and get this compendium so you can get to know the detailed stratigraphy of the entire country. So thank you very much for your patient hearing. So let me see if I can answer some of those questions.
Dr. Partha, thank you for a detailed talk. Starting from the showing the examples of various problematic conditions, and then you started with the SPT, energy efficiency related issues, and then moved on to the rock coring, rock related issues, and then a couple of case studies really highlighting how different soil investigations agencies are giving different results and what care should be taking. And it's really alarming uh, to see the practice what's been happening. If you are not paying enough attention, where we end up, all the projects where we end up. It's really good to know that some of these projects are spending more time and more investigations to get more details and optimizing the foundations. That's good to
Yeah.
hear.
One thing I want to tell everyone here, you see, there are few case studies, maybe 10 projects, right? If you sum total the cost of those projects, okay, and the amount of that money that you wanted to do the right thing at the first place, this is very, very small money. No, although initially it appears to be big, but it's not so. So I think we need to change our mindset and bring in specifications, using technology and the right people on the job that can actually take away all the risks that can come into the project.
Yeah, good. So looking into questions and answers, we received few of the questions. Others, please, if you have any questions, please type in. We'll try to take a few of the questions as considering the time limitation, and we'll try to address other things later in due course if time permits. So I would like to take one question which was mentioned. An anonymous attendee, what are different types of soil conditions and what do they mean? Weathered rock, overburden, and so on. I think it's very preliminary. Maybe we just quickly take to add something.
Yeah. So overburden is all the soils where you have N value of up to 50. And beyond 50 is the refusal stratum, it's weathered rock, transition zone, and then you get into a sheet rock or a fresh rock. So that's the general stratigraphy in a residual stratum. But in northern part, you don't get any bedrock in India. So you get alluvial deposits. It's sand, silt, and sand clay mixtures. It's as simple as that.
Okay, thank you. So there is one more question. I think it's Jeevan Bila. They are putting the comments on CPT in general. CPT has advantages over SPT, but we are not getting the sample. His question is, how popular is the CPT testing in India?
Yeah, so it's not that popular, but CPT is picking momentum in the country too, because obvious advantage that you can get the material because there's no disturbance to the test is an in situ sounding. And also the information that you can get from CPT is very well established with correlations to the settlements, the constraint modulus, the over consolidation ratio, relative density, etc., etc. Now there are many projects that specify CPT, but apparently the way that the on-land infrastructure space is looking at CPT has limited application because you are only doing the ground mode. You're not doing a downhole mode unlike we do in the offshore. But it's very, very good to characterize the ground until the penetration, the CPT penetrates. And it will be very helpful for arriving at your ground improvement parameters in many cases. So it's getting popular. I hope in the next coming few years, it becomes a part of routine investigations.
Even geotechnical testing agencies also, only few of them are equipped with CPT, right?
Yeah.
One is the client preparedness and the service availability.
Yeah.
What do you comment
and also
on
the
this?
cost. The other thing is the cost of the tools. The calibration is not available in the country. So once in every year you have to calibrate it. So you have to send it overseas and come. So probably if that can be equipped and available locally, then it becomes a routine practice. I hope it's not too far away. So we will try to get that. There are some research being conducted to build indigenous local manufactured cones. IIT Bombay has been successful in getting at the laboratory scale. Probably if can bring that into the field level prototype that can have the local conditions and manufacture locally. But regardless, I think it's getting popular. I'm sure many will start using it.
Yeah, I think that's a good thing. So made in India things comes means calibration and other things also would be easier now. One more question. This Roop Kishore is asking how to determine the bearing capacity for already constructed building without disturbing the main structure. What field test?
No, you have to reassess those structure. If you have the data, then you collect the data. If you're not, then you go and drill the holes next to the foundation to see what kind of stratigraphy and strength parameter that's condition exist. Then make the assessment based on the current structure. So yeah,
Good.
I'd say it's a routine procedure. Without building, you are doing it now. With building, you do it again and reconfirm that.
So there's one more question by Manish. What should be the property if we have contradicting
Priority.
geophysical data, in situ data and laboratory data? It's completely everything is contradictory.
What should be the priority if we have contradicting
yeah.
geophysical, in situ, and laboratory data? So I would give in situ data as the first priority. If it is properly done, particularly when you have CPT data, we give more reliance to CPT data because geophysical cannot give engineering parameters. Okay, so it can only help us identify the stratigraphy and lateral continuity or discontinuity of the information. Laboratory test depends on how is the quality of your undisturbed samples. So I just now showed few examples of conflicting, and this simple conflict between lab and the field results. Why we say field results are more reliable? Because for particularly offshore, even for pipeline project, you take the samples, you make measurements of unit weight and moisture content immediately on the vessel itself when the samples are out. So that first-hand information is always the best information. And after 1 month, the samples goes to the lab. We don't know what condition samples goes to the lab. So that's where most of those parameters are tested offshore to give a real-time information and first-hand information. So geophysical always is complementing to geotechnical. So we have to use both the data together. If you have conflicting results, I'm sure many times you have conflicting. So you exercise your judgment to see what is more appropriate, bring in your experience, look at your nearby structures, and then make the decision.
Okay, good. So one interesting question here, Sandeep, how to calculate the shear strength parameters when we get the refusal data, and when do we terminate a borehole?
It's a good question he has asked. See, if you encounter a refusal stratum and then you tend to put your coring tool, a triple tube core barrel, probably in next 2-3 meters, you may get your refusal samples, wood core samples, and then tend to get into a bedrock. Usually the termination into this rock will be 5 meters into the rock where your RQD is more than 80%. Many specifications put that. Otherwise, if it is a very poor rock, then if you are going for for critical foundation, particularly pile foundation, your rock socket should go to that depth as per the codes. The IRC recommends some guidelines. The IS code recommends some guidelines. If it is poor rock, then you go to some 3 to 5, 6 diameters, or it's 2 diameters. So that's how it's project specific, site specific. You tend to terminate the boreholes.
Relating, I have the one comment or question. Like we have shown one slide where there is an SPT refusal, but the split spoon sampler is empty. So what could be the reason? Is it that it was hitting only one stone, so it's not penetrated?
Yeah, you know, it's very, very good question, Professor. See, if you get a gravel block, a stone, hitting the split spoon sample is blocked. You won't get any sample, and it will end up having damage to the shoe itself.
Exactly.
Or you may not have a refusal stratum, you have a overburden transition to a fresh rock. You're hitting a fresh rock. Also, you will not get any sample. One example I'll give you, I recall several years back, maybe 30 years back, in one of the site, when you look at an excavation, there's a gravel band that is there around 1-2 meters depth in Bangalore. Okay. People tend to use SPT in the gravel band, it rebounds. No, then you tend to damage when the hammer jumps, you remove it. 3-4 boreholes at 2 meters, 1.5 meter, 2.5 meter refusal. Everybody packed and then came back to the office. I was writing a report. We didn't have mobile phone 30 years back. Everybody came back in a vehicle. Then you say, what happened? Is 1.5 meters, 2 meters refusal. Hey, how come? Cover, we'll go back. The procedure, when you get refusal at a shallow depth, the next step is to take a tempered cone, DCPT cone, dynamic cone resistance cone, put that and drive it. Even the cone should get refusal because the cone is so strong and hard. We used to do oil temper in a kulme, go there, heat the oil, dip it. If the cone penetrates, that means there is soft layers. They said, okay, let us do the cone. So you start driving the cone, after 10 blows, 20 blows, it started penetrating. Then there was one guy, operator Nagaraj, he was sweating, I said, no, you cannot deviate the procedures. I learned it 30 years back. Okay, refusal to SPT, you do a DCPT. Okay, now in that gravel band, it was punctured. And then you got very small values of 8, 10 below that. And we gone up to 7 meters to complete it. It was 3-floor building. This information is not available to anybody here. So this is where this experiential learning is necessary for our younger friends. That
So
we
what
can
you're
share.
saying is dynamic cone should be complementing along with the SPT.
Not complement. No, not complement.
Yeah.
After SPT refusal, if you want to terminate, you try with DCPT cone, and also you should refuse. Now, the second, if it's shallow depths, always the DCPT, you can drive it, okay? Because it's an in situ test without borehole disturbance or a drilling disturbance, you get an in situ sounding. If there is a shallow depth of refusal, always try to correlate with your DCPT. So that will give, because your borehole disturbance can give very less N values. Auger borehole, I showed you that. No, even you can have in machines also, the drill fluids are not washed. The drill cuttings will settle down. You get very loose values.
But
so,
how frequently this DCPT is being used, dynamic cone? Is it well practiced? Means many of the reports I never seen any DCPT data. Right?
We practice. Whenever necessary, we practice because you are owning up writing a report. Okay, just doing this DCPT test is very simple test. We practice, but it's not specified anywhere.
Correct.
So, but it gives you a great advantage of having one.
When you are doing SPT with the hammer and all those things, and doing DCPT is just changing the cone, right? Simple.
Not in the same borehole. DCPT should be done adjacent to the SPT. Yeah. So if you have a CPT, you can push the CPT cone. But right now, CPT is not that popular. You can still do a DCPT cone. So another reason of doing DCPT cone is, see, you have a very weak material in the top, some 6, 7, 8 meters, right? But if the area is too big, you cannot keep doing boreholes everywhere. Either you do the CPT is a common practice right now, or you can also do a DCPT and see at what depth I'm getting a competent material. So I know what is the thickness of my ground improvement across the site. So it's very, very simple. So you put a cone, probably you don't need to even thread it. Put a cone, drive it and leave the cone there and pull out the rod because it's easy. If you thread it and pulling out the DCPT cone is very, very difficult things. So there are many ways that can do.
Thank you. Thank you for your inputs. Arun Kumar is asking, you have calibrated the energy level. Can you give some information of your experience? Energy level calibration.
So energy level, we use an instrumented rod with strain gauge and axometer. It's the same pile driving analyzer that we use for deep foundation testing that give you what is the energy transfer to the drill rods. So our potential energy for SPT test is your 65 kilograms hammer and 75 centimeter as per the IS code and 762 millimeter as per the ASTM code. So how much of that energy is transferred to drill rods is measured when you are using rope and pulley. So you just pull the rope and drive it. When it's going through a pulley, most of its energy is already consumed, and is very, very well documented that your donut with the rope pulley is giving you only about 40%. Sometimes even we have seen very less, not even 40%, about 30% or less. So if your energy is only 30%, it tends to over predict your SPTN values and the bearing capacity. But on the contrary,
also showed the higher energy level issue also.
Higher energy. Hydraulic hammers with automatic hammers, hydraulic rigs gives 90% energy. And if you're not correcting that, probably you are not economizing foundation.
I think that's a good case study you showed.
Our IS code 2131, just now the recent version, they introduced the energy transfer. And also you have this liquefaction code with appendix F. It says probably you use 80% energy transfer, because they assume that this auto trip hammer, the automatic hammer, should give a minimum of 80%. That's where the correction factor of 0.8 is mentioned. But we take it wrongly and say that every time auto trip hammers should be 80%. Not all auto trips will give you 80%. Better you calibrate the rigs that is operating on a project before the start of project, and probably if it's large scale projects, periodically. High speed rail, they wanted rigs after every 10 boreholes to be calibrated. That was a practice.
Okay. This is one more question from Vinod. So what it's saying is, what is the termination criteria normally need to be considered? Is it TCR or RQD?
RQD is again a misnomer. 9 centimeters of course, 10 cores will give you 0 RQD. 11 centimeter of 10 cores will give you 100% RQD. So yeah, physical observation of the material, whether there's real breakage due to mechanical disturbance, or is it a joint in the core samples, is very, very important. So generally is RQD more than 80%, 5 consecutive interval or the run. That is where you see that there's a massive rock that is available and you terminate those boreholes. Or you just go with some project guidelines if they have any other guidelines.
Yeah, next questions is, in case observed discrepancies in the test performed, how to judge which data is correct and which is not? Tricky.
No. That is where you need that skill, expertise. So go and learn in the lab. Every test that you can perform, please learn. It's just not for people who conduct the test. This information and knowledge is required for all stakeholders, I would say, that is involved in the project. Because I may not be doing the test myself, but I have to approve the reports. I am a quality engineer. I have to drive quality. Unless I know how to identify these cases, it's be very, very difficult. So you need to have that experience. Today, technology is available. Information is available for free. 30 years before, we didn't have internet. We don't have information. Today, ChatGPT, everything will come today. But what is lacking for our young friends today is the experience. So that's where that experiential learning is very, very important. My advice to all the youngsters here, you go and have one mentor for you. Okay, so who you look up, that they are going to help you build your career, follow them. So, okay, and then learn from them their experience, because the experience is invaluable. But if you can augment that experiential learning with the technology, I think you will learn 3 years than what I have learned in 30 years time.
I think I would like to add one comment here.
Yes,
most of the agencies are the testing agency. I think some expert who is preparing the report, who is writing, should visit the site, should have some observation of the soils. I think that's what I'm understanding from your observations.
I think 2 case studies.
Simply not taking the values from the field to the office or lab, writing report, but having the observations is important, right?
Correct. At least 2 case studies I showed was actually prepared by a very well-known expert. Not gone to the site. Not gone to the site. Exactly. Not gone to the site. There was no samples, not gone to the site. Somebody come bring the data. Okay, then I write the report for him. It's a disaster. No. Unless you have that experience. First hand is always the best information that you get.
I think this is what something is lacking. From the office to field, there should be some good coordination. Person should be directly seeing the thing that should be insisted. That's good. And Vikash is asking, is IS 2131 draft code, is it published by BIS? I think it's...
I'll have to check. I had to check. It's not published. It was under circulation. I'll have to check. I'm not sure. I can check and come back on that, please.
Last couple of questions just to close. How can SPT test values can be filtered while adopting the parameters for design purpose? Please suggest any code provision for the same.
No, there's no codes for that, how to filter it. What we normally do is put the SPT all together, do all the corrections, particularly the field corrections. Then you follow the codes, overburden and others. There are other corrections too, that those other corrections, the rod, borehole things are all very small, insignificant corrections. Field corrections, overburden corrections, you put everything together. Then you draw the stratigraphy, take the average N value for each of those stratigraphy. You can, and then you build your ground model based on that. How to know whether your SPT is the correct value or not, unless you have physical observance on the samples. Suppose the split spoon sampler you open, the entire split spoon sampler is bentonite muck, then your SPT is no longer valid. Okay. There are cases where increasing SPT, suddenly the SPT will drop. I'll give you an example. In Bangalore, I tried to map that one layer of silt is there from Hebbal flyover until the airport. It's somewhere happening between 10 to 15, 16 meters depth. Any depth, you can get a thickness of around 1 to 2 meters. Pink color silt with mica. The N value in the overburden is 25, 30, 40. Suddenly, when he hit this silt layer, the N value will drop down to 14, 15, 12, 17. So we have to capture that layer. Otherwise, it's detrimental when you have the deep excavations and put your foundation just on top of the silt layer. It undergoes large compression, settlements. So you have to map that. Many times what happens, Bangalore is residual deposit, no problem. So we tend to ignore those values. And then we tend to predict or recommend a very high bearing capacity, 150 metric tons, ton per meter square, 120 ton per meter square. When that silt layer comes, you will have to be very, very cautious. We had some conflict debate with some projects. And then he said, no, we will not give because it has investigated. And we know that this silt layer is there. The best practice, again, I should acknowledge one of my engineers who worked 10 years back on a project. The moment the N value drops up to 30 and above, you cannot collect undisturbed sample with our conventional procedure. The moment N value drops, you have to collect an undisturbed samples. It was a procedure that we written when we started ISO in our company in 2010. And I'm very proud. I didn't show that because of time, that immediately the silt layer dropped and we have that in all the boreholes, the undisturbed samples collected. It was so valuable information for us at that time, and I'd still use that information for all my presentations.
Okay, good. Thank you. One last question. In what cases we should consider dilatancy correction factors on SPT
as
values?
Per the code, it's fine science. Below water table, you apply the dilatancy correction.
I think dilatancy, is it internationally applied?
No, only IS code is there. I don't think other codes use it, but we also are discussing in our recommendation that we should ignore this. But to be on conservative side, they wanted to have this dilatancy, but now the field energy corrections becomes into the code. Probably we can eliminate this dilatancy correction.
Yeah, when the energy is other things are there. Okay. So thank you for your detailed explanations of various things, and good to see wide spectrum of your experiences. And I was afraid of seeing that one, that offshore rig while failing, people are running. I don't know how they escaped. These are the questions coming to me.
They had the life jacket, and it was actually a project in Middle East with the jacket capsized. Two reasons. I don't know the root cause of it. One, uneven seabed, probably, or maybe the temporary support system to hold that jacket before the piling is driven. Probably is under predicted. It's not designed properly. The design, the shear strength could be very over predicted. So therefore, the bearing capacity is under predicted. It may not hold. So I don't know the root cause for it, but any of these cases could lead to that incident.
Yeah. Okay. Thank God. I hope people are safe or something.
I hope so. Yes.
Yeah. Good. Thank you very much. Wonderful. We have one
Yeah,
comment suggestion in the chat box saying that some next webinar on the pile foundations, construction of pile foundations, mentioning about bentonite liquid or something, the slurry, stabilizing the borehole sort of aspects. Maybe we can take up.
Yeah, we can discuss that. There is another committee on deep
Another
foundation.
committee,
So
maybe we can just see.
yeah, we will
Pranav,
inform
you
them.
can note down that one and we can suggest and we can plan one webinar on that one. Okay.
Sure, definitely.
Okay. So with this, yeah, I hope all the participants got good insights on challenges in geotechnical investigation, what special care should be taking. Okay. And as geotechnical engineers and practitioners, we have to encourage the high quality geotechnical investigations in all of the projects, highlighting the small amount of the geotechnical investigation out of the big amount of the whole project. And we have to ensure, we have to show the optimization of the final design without wasting the energy and resources as a whole. That's, I hope you could learn something. And I thank Dr. Parthasarathy for sharing his experiences and highlighting the importance. Thanks, Pranav, for giving me this opportunity. Over to you, Pranav. Yeah.
Thank you.
Thank you so much, Dr. Parthasarathy, and thank you so much, Professor Murali Krishna, for moderating this session and a wonderful lecture from Dr. Parthasarathy. So now, before we close the webinar, I'll just give a quick recap update on the DFII India 2024 conference for the attendee who are still here on this webinar. So you can just have a glance over the keynote speakers. We have Professor Alessandro Mandoloni, the chair of TC 212 committee, Dr. Venu Raju, Professor Madhav, Thomas Dominski, Dr. Parthasarathy will be with us again in the 2024 conference. And Mr. Alan Marin, Lucky Nagarajan, they'll be delivering a keynote together. Plus, we have a special session on foundations for tall buildings. Here we have again Professor Mandoloni, Professor Deepankar Chaudhary, Mr. Satyajit Vaidya from Langan, US, Dr. Marwan from Dubai, and Professor Robert from Katzenberg Engineers Company. Then we have WIDF session where Audette De Silva, the first chief engineer from PWD Goa, will be sharing her insights with the conference delegates. So I encourage all of you to register for the conference. We have received a lot of support from the industry, and we hope to see you all in Goa. So thank you, everyone. Thank you to the speaker and moderator again, Dr. Parthasarathy and Professor Murali Krishna. So thank you. See you in the upcoming programs and conference. And this marks the end of our session 1 in this webinar series. Thank you, everyone.
Thank you.
Okay. Thank you all.
Thank you, sir. Thank you, sir. Bye.